Yeah, so panels used shall be number of panels in cube n shall pass in cube x. I know my variable naming game isn't that high today. Maybe because I am not high. Maybe I should light up. Okay, well, that's number of panels. Maybe I should prettify this thing. I think I need to read that book called Code Complete, because it's yeah. Rooms left to construct is that if rooms left to construct. Alright, so then we say last phase, and then we say so define here number of panels in not cube but a square in x by y square. And if here also we say x, y, and here we always know that the bottom is not needed. The bottom panels are excluded. So now we just have to like figure out if we have like, for example, I don't know, again 2 times 2 square of so-called rooms, how many panels do we need? So here I guess at first we have like always the height of 1, so 1, and if that is x and that is y, well, I say 1 times x. Oh, actually 2, because 1 is here, 1 is there, so it's 2 times x plus 2 times y. Plus x times, not plus, x times y. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, that's 8, 8, 9, 10, 11, 12. So that I counted them, so this should also give us 12. 2 times 2 is 4, plus 2 times 2, 8. 8 plus 2 times 2, that's 12. Alright. So right here, say the bottom panels are excluded, and we just return 2 times x plus 2 times y plus your mother. No, just kidding, x plus y. Alright, so here we say panels used is plus equals the number of panels in x by y square number of panels in x by y square, and here we say what? Just cube x and cube x, so that is so that is n times n, and also one for n plus 1 times n. Copy, paste, cube plus 1. Alright, and then we shall say rooms left is rooms left to construct is minus equals cube x times cube x plus cube x plus 1 times cube x. And I said construct, but you should say construct. Alright. And then here is kind of the same. Here we say, okay, we have the middle phase over here, where we just say this one, panels used, copy, paste, say rooms left to construct or like so, without this one, and over here we just say, yeah, so, but in all cases then we must see, we just say panels used plus equals number of panels in x by y template, number of panels in x by y template with z rooms. And I say x, y, and z, and the same over, oh shit, and the same over there, and the same over here. So we say copy, paste, copy, and then paste, z rooms, number of panels in x by y template with z rooms. So here we define it, we say define number of panels in x by y template with z rooms, and we get x, y, and z inside, and that's like the last thing we need to solve, because then we just say return panels used. Yeah, because for this one, what are we doing? We have an empty template. For example, oh, let me say again. again. Shit. The bottom panels are excluded. So here we have a panel of 3 by 4, so that's 4, that's 3. Okay, so we need to make 4 in that. 1, 2, so that's 1, 2, 1, 2, 1, 2, 3. Okay. And let's say, okay, so that's the template. And to say, for example, if z is I don't know, 6, we've got 6 of them filled. So let's use streamer. So this one is now full, this one is now full. 1, 2, 3, 4, 5, 6. Yeah, alright, this then is pretty simple. And we know they want to be grouped again. Either it is yeah. All right, I see a pattern over here. So we could get something like that. Or if we pick another color, we could make something like outline. Yeah, fuck, something like that. Yeah. There, if z, damn, if z was 5, 1, 2, 3, 4, 5. That's also 1. That is also 1. And again, I know what to do, I just don't know how to make an algorithm for it. Because like what does it mean? I mean, if z, we could quickly divide it, like, and if say shit, if we say where were we? Oh yeah, if z modulo 2 equals 0, so if z is even, we do let's see for if z modulo 2, we just say yeah, we just say z divided by yeah, or do we say that? that's x by y square. Oh, x be there or be square. But this is for yeah, because that's a square, but we're calculating a different thing. So let's just make a quick quick drawing of what am I thinking right now. So let's say we have I don't know, we have something that is 3 times 3, and we have something that is 2. So 3 times 3 is 9. And how do we get 9 also? Well, yeah, we can. Okay, 3 times 3. What if we have, I want something square, like 2 times 2. And for example, 1 times 4. Oh no, it must be even. Fuck. Yeah, you get 4, 2 times 2, 3 times 3, 4 times 4 is 16. So 16 can be described as, alright, 4 times 4 and 2 times 8. So if it is 4 times 4, we say go fuck yourself. Shit. Yeah, just like so. Alright, and 2 times 8 looks like so. One, two, three, four, five, 6, 7, 8. Like so. Say 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so here we have how many of them? 1, 2, 3, 4, 1, 2, 3, 4. So it's say 4 times 4, so those are all the sides, and also in the front is 1, 2, 3, 4 times 4. So it's 4 times 4 plus 4 times 4. But here is much more, I know, because it's 2 times 2 plus 1, 2, 3, 4, 5, 6, 7, 8. Oh, so it's 2 times 8 plus again 2 times 8 and the up. So here we have, so 4 plus is just 16 plus 16. But over here we've got 4 plus 16 plus 16. So then we have a problem even over here. Now even over here, number of panels in square y, I mean x. Because 2 times x, 2 times y, 1x plus y. I mean, that counts in over here, but not over here. So yeah, in the last one we need to like calculate by ourselves the smallest number, and I think over here that we can help with this are with our algorithm, because it can happen that these x, y's are very large numbers. So over here we can maybe say, well, what if we just say pass and just return panels used? Will some of them be green? Will some of them be red? Name x is not defined. X, Y, Z, x is not defined. Okay, yeah, whatever. Let's enter that x, y, z. In the last phase, the template is cube x plus 1 is cube x plus 1, and here it's cube x plus 1, cube x plus 1, and here it's rooms left to be construct. I thought it's add in the end, but whatever. Here it's cube x, it's cube x plus 1, rooms left to be construct. Over here is just cube x, and over here is cube x, rooms left to be constructed. Construct, yeah, that is now messing with my head. Constructing, constructed. Alright, let's test that out. Name is not defined. Okay. Copy. Paste. The rooms left to be constructed. Construct. Welp. Paste. Yeah, I see like the shift in my thinking, because if the shift wouldn't happen I wouldn't have noticed this thing. So something definitely happened in my mind over here. Unsupported for int and non-type. At which line? Line 4, line 37. Let's say line 37 plus equals. Oh, this should always like return something, so return 0 for now. Oh, okay. The first test passes, 0, 0 passes. 1, 2 should equal 6. Okay, why? 2 6 should equal 11. 1. Yeah, I have, like, right now I have a like, what is 36? Is 36, it's not even, yeah, 4 times 4, it's 27. 27 plus 9 is 36. Yeah, this one should work, but it ain't. Oh, maybe we need to, like, that equals, say that equals, oh, now, 36 still doesn't pass. When I came out of my mama, I was on welfare. 37 years later, I'm still on welfare. Oh, hold up. How much did ODB leave? He was how many years old? Yeah, quite some. 30. He was 30. Fuck, shut up. He was 36 years old when he died, and he released when he had when he had released Nigga Please. He was how much? 99. So we say 8, 8, 6, so 6, 7, 8, 9, 31. So here he was 31 years old when he released this. So it's like 31 when I came out of my mama pussy. I on welfare. 31 years later, I'm still on welfare. Alright, so what the fuck is wrong with this one? 2 should equal 0. Alright. I mean, I could at least finish this thing, you know. Number of panels in X by Y template with Z rooms. It should be quite simple. Regarding that, we have made a universal one for any room. Because we're basically doing something like this. Ugh. 1, 2 should equal 6. Why would 2 should equal 6? Pop. Yeah, like this one. So yeah, we're basically constructing that one. So then we say if number of lines divided by 3 is 0. So yeah, here we must, like, which number of lines, so to say, we are at. Maybe our first algorithm would be a little more help here, but it is so weirdly constructed that we must find our way around it. But we got the understanding, so that's X and that's Y, and you also go, okay, let's do it here. xy. You always go 5, 4, 4, 3, and then 4, 3, 4, 3, 3. So we don't even need the first two parameters, like the size of the template. You just say, or maybe we do. Yeah, we do. I think we do. Because here we say, we need to like construct. We need to construct it. But like on this size, it can be this big and that can be too big. Yeah, I'm afraid it can be a little bit too big. So if you say quit, then you say time it. Or did we use time it module? I'll just say like that on this, you know. I don't know. Where is that? Find size of cube. So if we copy and we say Python 3 and we say x is paste, and I say while n is less than x, we say n plus equals 1, say print. And now I want to see if that will happen immediately or if you will need some time. N is not defined. Well, fuck you. Okay. N is 0. Well, that to that. Yeah, it needs some time. That's too slow. That's way too slow to just iterate. Alright, so we shall find a square in that, but how do we find a square? 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 Hey. Maybe by calculating a cube again? Cube again? Maybe by calculating a cube again? By calculating a cube again? So here you say def size of the biggest. So here is not cube anymore, it's square. A square, already. And then we get the G. Again, we get X. Here it says always size is at 1, and here I will say while size times the size is less than X. Say size plus equal 1. And we return size. So that's the size of the biggest square. So we say over here we say size of the smallest square. Why is this called size of the biggest square, by the way? Size of the smallest square that contains x rooms. Oh, here is a size of the smallest square that something rooms, right? Right. So here I have another, like, a bit too much is this size of the smallest square that contains x rooms, and we say, what do we enter? We enter z. We enter z. Let's size square, and a bit too much. And how do we? How is pravokotnik called? Or just like wow. If you want to get married on Blade, you go to pravokotnik.com because you are a big square. If you it's like agency, you know. Huh. I don't know, maybe I know this, man. I'm not sure. I don't know. Maybe not. So yeah, how is that? Rectangle. The area of a rectangle is so we say a bit too much, and then we say number of panels is size of the smallest square that contains x rooms, number of panels in x by y rectangle. So that's rectangle, and I can't say rectangle, and you are really punished for changing variable names in this editor. You can see why by yourself. Rectangle, rectangle, rectangle. Here we say rectangle. rectangle is well, that is just stupid. Just stupid. Side. So we got side and side. We got two sides and we got the number of panels. So we have the number of panels and two sides. And then we can say smallest rectangle that contains X rooms. Oh no, that's square. Okay. Oh, you see 9 here. This is my comment. I made a comment over here. And this is getting pretty hardcore now. I'll get an error. And non-type. And over here we must reduce this number of panels because we say size of the square that contains side. So we'll say minus rooms are side times side minus z those are minus rooms, and you say if minus rooms equals to x or minus rooms equals to y, we just say number of panels is minus equals how much? Just say 1, 2, 3, 4. 2 for beginning and the end. So we got 2 for beginning and the end times 2 yeah, okay. 2 times 2 plus 2 times x elif minus minus rooms equals to y, say number of panels minus equals 2 plus 2 times y, and if all else fails you just say number of panels minus equals yeah, I'm a bit of a art. 2, so we say 2 plus 2 times minus rooms else number of panels minus equals 1 plus 2 times minus rooms, and then we say return number of panels. Just test that. Okay, 3 should equal 0, 12 should equal 11, 15 should equal 16, 1, 3, 1 should equal 7. Okay. Okay. Let's first solve this one. 0. So if we say panel count n, cube with 0, size of the biggest cube n is 0. Alright, so let's from the start of let's just say if n is 0, return 0. That's like an edge case that yeah, that should be better or just solved right at the beginning. Other thing, if n is 2, we say cube x, size of the biggest cube x, then size of the biggest cube n, say size 1, size 1 is 1, and here is 2, say 2, say 2 times 2 is 4, times 4 is 8, and it says, so it says return 8 minus 1. Size, okay. What a fucking joke is this? So it's cube. Oh, so it's 1, size is 1 then. Size of biggest cube is 1. Alright, so that is 1. So size of the biggest cube is 1. Alright, so yeah, then the panels used, number of panels used in cube n is 1 times 6 is 6 plus, okay, so here is 6, and here is 3 times, so 1 times 0, so it's just 6. Alright, panels used equals 6. Rooms left to construct is n, so that is 1 minus 1. So we say rooms left to construct is 1. So if rooms left to construct minus 1 minus that, okay, let's just do it quickly. If no, just print out if here we print out shit, fuck off. Here we print out elif, and here we print out else. Alright, here, yeah, here is if, yeah, so yeah, but it should be here, you know. Oh no, this, we're looking at this one, so it's looking at rooms left to construct. Oh, both of those paths. Oh, for 2. So this is log for 2, right? Yeah. Yeah, that is for 2. So we're like rooms left to construct minus is minus equal. Okay. So we're over here. And panels used, number of panels in x by y rectangle. So you say cube 1 1 1 1. So we say 2 times 1 2, and then here is 2 plus 1, 2 plus 2 plus 1 is 5. So here we get panels used is, we got 6 plus 5 right? Yes. Then rooms left to construct. So it's 6 plus 5 equals 11. And after that we say rooms left to construct. Maybe we should say over here, if z equals 0, return 0. Maybe then the third test shall be green. Yeah, then the third test is green. Alright, slowly getting there. Alright, n3. So let's do it for n3. So if n is 3, size of the biggest cube, if n is 3, then this is again 3. Panels used, number of panels in cube n. Number of panels in cube n. So it says here it's we say yeah, maybe we should delete all of the things we haven't written. We delete that, we delete that, delete that, delete that, we delete that. So that's 3 panels used, number of panels in cube. So we say panels used, yeah, it's number of panels in cube and cube x. Oh no, cube x is 2, not 3. Size of the biggest cube x here is 3, size 1, well, 1 times 1 times 1 is less than 3, 2 times 2 times 2 is 8, yeah, so that is, oh, okay, so here we say still 1, size of the cube is 1, lucky I went through. Panels use, number of panels in cube n. Number of panels in cube n, I think we can agree it with 1, that is 6. Rooms left to construct equals to, so that is 3 minus 1 is 2, rooms left is 2, and we are dealing with the elif statement. Yes, we're dealing with elif statement. So it's rooms left to construct minus, so 2 minus 1 is more than 0. Yeah. Panels used, so we say panels, oh shit, better comment it out. Panels used over here is just a second. Alright, so yeah, panels used over here is number of panels in x by y rectangle, and cube x is 1. So here is panels used is again plus without bottom panels, of course. So we see 2 plus 1 is 5, so it's 5 plus 6 equals 11. Rooms left to rooms left to construct, rooms left equal to, we got 2 minus 1 equals 1, and over here panels used. Number of panels in X by Y template with Z rooms. So it says cube X plus 1 in rooms left to construct. So here we say X is 1, Y is 2, and Z is 1. So size of the smallest square that contains X rooms, Z. So side should be. Alright, so we go over here, and here is input 1. 1, so size is 1. 1 times 1 is less than 1, so it's 2. So we got 2 over here, and it says size of the smallest square. Well, that's a mistake. It should be actually that expression over here. Maybe that shall make our third thing pass. Oh, and it doesn't pass this one then. Alright. Yeah, oh yeah, so that fixes that one, you know. But it doesn't fix that one, that one, that one, that one. There is no equals, then that one is that one. So I say size plus 1, so we return size. Return size if or return size minus 1 if size minus 1 times, yeah, look, it's getting complex, and size minus 1 equals X, else return size. You know what I mean? Now both things should fly. Alright, they don't fly. Print side 1. Oh, here it's not even printed. Else maybe return alright, say what is that if comprehension? I'm doing that. All right. Oh, this is nothing. 3, 1 side Yeah, that's what I get for being a dumbass motherfucker and changing stuff on the go. Everything go, we're on the go. Why, fuck you. Okay, so we say size of the smallest square that contains x rooms, z, and here we paste in 1. Over here that contains x rooms. Yeah, that's just false, you know. So we get returned, like if we print side, you know. I think we get returned 2 in that case. Ah, it's returned 1. Why is it returned 1? So this is 1, 1. 1 times 1 is less than 1. 1. Okay, so that is 1. Never mind, it wasn't even a problem. Lol. Number of panels in x by y rectangle. So let's say number of panels, number panels, and now it should be 5. Let's say this is 1, 1, 1, 2 times 2, yeah, that's 5, minus rooms is 0. So that's the problem. Minus, oh, so minus rooms. Oh, okay, yeah, because like where we are here. Minus rooms are number of rooms that we must remove. Okay. So elif minus rooms equals 0, then just return number of panels. Like number from is 0. Alright, so now why does this one fail? 7 should equal 6. Failed for n is 1. 7 should equal 6. Are you serious? One, 6. Alright, so here I say if rooms left to construct equals 0, then just return panels used. Maybe let's just hard code this solution. All should pass. Alright, and failed for 1 to 9 should equal 141. Yeah, it's called elif. So let us solve it for this big one. There should be no values over here. Okay. Something needs to be repaired. Now at first I'll just go through that. So count x, cube x, so n, and then n is 3, 6. And cube x, size of the biggest cube n. Alright, so cube x. This is x, 3, 6. This is x equals 3, 6. Size is 1. So it goes size is 2, and that is 8, and then it's not contained. And then size is 3, 27, that is not contained, and then size is 4. And so returned it is size 3. So say cube x is 3, and we say print cube x is, and then cube x, and let's just test it out. It is 3 indeed. Alright, panels used, number of panels in n cube, so cube x is 3, and panels used in cube x, so it's 3 times 3, 9. 9 times 6 is, let me write it down. 9 times 6 is 45. 45 plus, here we have n times n, so that's 3 times 3, that's, so 45 plus, oh, so, okay, so incidentally here is also 3, so it's 3 times 3 times 3 is 27, 27 times 2, which is 54, 54 plus 54 is then 109. So panels used should be 109. So let's print it out. Panels used are, panels used should be 009 and 10. Oh, there, 108. Oh, because, well, for 54 plus 54 is 108, not 109. Lucky I checked. Hee hee. Rooms left to construct is n minus cube x times cube x times cube x. So it is 3, 6 minus 3 times 3 times 3, which is 27, and rooms left are then 9 or 11. So that's from 7, 9. Yeah, that's 9. And then we get into, okay, so then rooms left to construct. If rooms left to construct minus and minus that is more than 0. So we are exactly here. This one should pass down to else, not if. Rooms left to construct minus is let's test that out. Okay, nothing changes, which is good. And what is this number over here? Something is printed. 1, 1, 2, 1. Print site, yeah, fuck you. One to 9 should be 1, 4, 1. All right. So we are in else. Super. Number of panels in X by Y template with 0 rooms. So cube X is 3. 3 rooms left to construct. Rooms left is 9. So then you say X equals 3, Y equals 3, Z equals 9. Size of the smallest square that contains X. Rooms Z. Size is 1. 1 times 1 is less than 9. 2. 2 times 2, 4, less than 9. 3. 3 times 3 is 9, less than 9. No. So there is returned 3. And we have returned that, and we know that here is 3. Number of panels in X by Y rectangle is, and side is both are 3. So we say 2 times 3 is 6. 6 plus 6 plus 9. So number of panels 12 plus 9 is 21. Let's check it out. Print number of panels. Number of panels. 21, yeah, that's right, it's 21. There's 5, here's 21. Minus rooms is side times side, 3 times 3, minus Z. So minus rooms is 0. If minus rooms equals that, yeah, nothing happens. It gets into L if minus rooms is 0. So return number of panels is 21. So here we say panels is 21 plus 108. 108. And we return that. And that is apparently wrong. Because 21 plus 108 equals 129. And it should be 141. Oh, I understand. In all of that is the problem with this one. Number of panels in the rectangle. The thing with number in panels in rectangle is that you have also them in between. 2x times 2y times yx, and then it's actually plus y times x minus 1 plus x times y minus 1. Test it out. All of them pass. Oh fuck, I hope all of them now will pass. Oh. Oh no, shall it time out again? Oh fuck me if it times out again. For real, come on. Oh my god, it will time out. Oh no, it's actually wrong. And then I guess the max buffer, yeah, and then it times out. So first it's wrong, and then it also, and then it just times out. Okay, and then I guess these are all correct. No, they are not correct. This is my 3 hours ago was that. Well, fuck. If we train again, I just want it to be like you know, anything but execution timed out, you know. I just want like it's wrong, not execution timed out. Could we make our code faster? So let's just say I want to, let's see how long it comes. Def panel count, get an n. So we say x equals yield. No, I want to count how many times the like function calls is 0. Every time panel count is called, we say function calls plus equals 1, and we print out okay, we print out function calls. Okay, nothing is, okay, because both are called panel count. Ha ha ha. Ha 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 ha. Reference before assignment. I need to like, what is that? Global. Invalid syntax. Python global variable. global var. So here we say function calls is 0, and then function calls +1, print function calls, and here we say, let's say global function calls 1 2 3 4 5 6. All right, cool. Say what happens. What is the exit code? Okay, so it's one, so it's like 101,012 test cases. And if we move that over down here, just delete that, rename this panel function. This should be all green. All right, and now let's say how far does our function come? Mm-hmm. 1 2 3 4 5 6. Oh, it comes pretty close actually. There is only how much? Let's calculate that. So if maximum amount of test is 100,001 and 12 minus 98753, we are only left with that, you know. So let's try that again to see if it can be a little bit quicker. Oh, we mustn't forget the code is still wrong. We must repair the code also. So here is 98753. All right, so that's all the same. All right. Let's see if we can make a code that goes through all of it. Even if it's not completely right. Not that. What is it? What are we troubleshooting? I know a good article that says how to make the runtime shorter, how to optimize the code, generator expressions, names of large numbers, quintillion, scientific calculator, continents. Okay, how to declare global variables, maybe it's here. Let's just check it. How to optimize Python code for speed. Using Python. Python is fundamentally a superset of Python, meaning every Python code is a Python code. Python is also used to interact with C or C++. What it does is it converts files ending with pyx to C, and then these C files, which kind of we're not going to take this longer route as part. We'll be using Python cell to run it in our notebook. To do so, we'll need load Python. Let's just Python magic. we see with Python that the function which was called only take 149 nanoseconds of the number in Python. And over here, just random math O is much more. Okay, so we say, so yeah, let's just use that, you know, time it, right, copy, oh, error syntax, I guess so. Say so the words, can you use Python? Yeah, I can't. So this article does not help us. For performance to speed up Python code, get the whole setup ready beforehand. Fire up your Python editor beforehand if you are writing. Hacker Earth. Okay. Get the whole setup ready beforehand. Get the whole, okay, fire up your Python editor beforehand. What? If you are writing your files in your local, create a virtual and activate it. Which might and that is to std. I generally use Python and have a pipt in my virtual environment. Refactoring, okay. Get the code working first. That's your most, for the first iteration, make the code work. Strings, do not instead use this. You can use some Pythonic code constructs that give us better performance. Let's look at them below. Alright, string, do not use this below construct, plus equals, instead use this. Okay, so this plus equals is making it confused. And I have a bunch of these things. So we make attempt of that again. It takes 12 seconds, of course. I shall use, this is because in Python string is immutable. Language constructs. Alright, so this is still using about the same, yeah. Make functions of your code, and although procedural code is supported in Python, it's better to write them in functions. Code reusability and champions of TDD. So def main ix range pass is better than def main. It's faster to store it in this Stack Overflow post. Okay. And maybe it is even slower because of that global variable we use. Well, fuck it. I would recommend you keep the procedural code as little as possible. You can use the following standard template. Solution main. Okay, use the standard library. Instead of this, use this. Standard library. there is also the list expression or generator expressions. Permutation. Wow. Okay, generators. Which returns a generator iterator. Operation average case, worst case, n, append, slice, k plus n, what the fuck? Oh. The state of the generator function is frozen. The values of all variables are saved and the next line of code is recorded until next is called again. Yeah, I kind of got off at that one, but I'm back. I also got this nice book called Code Complete, and there is a whole lot of cool things in this book, such as refactoring, code tuning strategies, and code tuning techniques. Now, I know refactoring, you refactor a code that's working, and this code ain't working. Well, it works for smaller numbers, I guess, but not for the higher ones. So there are some generators, generator type algorithms and data structures, and if we look at our code and we see like what can be done, here is a while loop. We could make that a generator function, but I think that would just kinda take up time. Like the only thing that could maybe maybe this one. Why does code run faster in a function? Why is it faster to store local variables than globals? C Python. Global lookups are still pretty here is a small illustration on a local variable deficiency. Performance tips. Choose the right data structure. TBT. Omsk. Sorting. Choose the right data structure. Get it right, test it right, profile it slow, optimize. You can only know what makes your program slow after first getting the program to give correct results. Then running it to see the correct program is slow. When found to be slow, profiling can show what parts of the program costs. A comprehensive but quick to run test suite can ensure. Alright, so I guess all of the guides just scream in our face. Get the code right. And if we make an attempt over here, it says, we can't even know. I mean, we can know, I guess, when it's wrong, when it's right. And 25 is wrong. Now why? And 59 is also wrong. Why is N25 wrong? 103 should equal 102. Alright, and this is difference of 5. and this is difference of 4, 1, 4, and 2, difference of 1, difference of 1, difference of 1, difference of 4, difference of 2. So we're getting some minor differences right here, and then nothing upwards. All right, so let's sort out these minor differences. Let's pick one and do it, you know. For example, this 25, yeah, or maybe 30. Let's do this 25, because it's 25. Oh shit. Okay. Yeah, I really ought to clean up my working space. Put it on the floor. What the fuck is this mask doing here? Get the fuck out of here. Alright, always need a piece of paper and pen and pencil. So, for 5. Let's do it for 5. Okay. Cancel that. Oh, cancel that. 25, right? 25. Yeah, cancel that. Cancel that. Cancel all of that. Alright, so we say we start with 25, cube x, size of the biggest cube, we have that here 25. Here we say 1, 1, 1, it's not 2, 2, 2. Is still not right. 3, 3, 3, 27. So here is 27, and what is returned is 2. So you say print cube. Alright, so that's returned 2. I want to print it out. Panels used, so cube n times n times n is 2 times 2 is 4 times 6 is 24 plus 2 times 2 times 3, so 4 times 4, 12. 24 times 12 is 36. That's 36, right? Let's just do that here, like, yeah, so we say over here, say x equals what, 25, say while and size equals 1, say while size times size times size size is less than x, size plus equals 1. Return size minus 1. We're expecting to get a 2. Invalid syntax. Ah, okay, I know why it is invalid syntax. Because we're forgetting the spaces. Why is return outside function, man? What the fuck? Oh, it's actually right. They're just oh my god. Okay. Say well that and say size plus 1. See what size 3. Oh, and size minus 1 is 2. Alright, so we got 2 and 2 is here. That is passed into this function. Say 2 times 6 plus 3 times 1 times 2 times 2, 36. rooms left to be constructed is, alright, n is 25. So rooms left to be constructed is 25 minus, and here we say cube x is 2 times 2 times 2, 17. It was a very good year. Alright, 17, and then we see in which statement do we go to. Rooms left to construct. So we say if 17 minus 2 times 2 minus, then go like so. So we say 2 plus 1 times 2. If that is more or equal to 0, so we go over here. So we go over here and we say panels used. So we say number of, okay, panels used equals to 36 plus what? Plus what? We go over here. Number of panels in x by y rectangle, where we say 2. What are the cube x? Is 2, right? 2. So we say 2 times 2 plus 2 times 2 plus 2 times 2 plus 2 times 1, so plus 2 plus 2 again, so that's 16. So that's 16, right? And so panels used is, panels used is now actually 52. And at this one, right here we say panels used is panels used is yeah, that thing, but a little bit differently. And yeah, we say 2 times, okay, so x is now 3, so we say 2 times 3 plus 2 times 2 plus 3 times 2 plus 2 times 3 plus 2 times 2 plus 3 times 2 plus 2 times 2 plus 3 times 1, so it's 23. That's 52 plus 23. 23, which equals 52 plus 23 is 75, right? So over here we say if n equal what, 25, say print panels used. Alright, so here we actually go check it out. Yeah, we always need 12 seconds so everything can be run. Yeah. 75, and it is actually 75. Alright, we're doing great. So here we say rooms left to construct. Used rooms left to construct, so we say rooms left equals to, currently there are 17 minus cube x times cube x, so that's minus 4. That's everything is like so. 4 plus cube x, so 4 plus 3 times 2, 6. So that amounts to 17 minus 4, 10, that's 7. So that's 7. Rooms left are 7. So again we say if n equals 25. This one we want to print out and the number rooms left to construct. Okay. We can stretch. Alright, 7 rooms to construct. Always like her. Alright, and then just like panels used. Shit. It's always panels used equals to 5 2. 7 5 plus, plus what? Number of panels as template. Cube plus 1, cube plus 1, so you say 3 3 and 7. Alright, so you go here, x is 3, y is 3, z is 7. Okay, size of the smallest square that contains x rooms. Side. We must first delete this stuff from before. So side, size of the smallest square that contains x rooms. Let's just, we pass in 7. So it's, damn. Alright, so we say x equals 7, size equals 1, while size times size is like that with x, and we say size plus equals 1. And let's see what size is about. Alright, side. Side size is 3. Square that contains x rooms, so that's 3. Number of panels, side, so 3 3 in x by y rectangle. So that's 3 side, both are the same, and alright, Alright, we say 2 times 3 plus 2 times 3. Okay, so it's 2 times 3 plus 2 times 3 plus 3 times 3 plus 3 times 2 plus 3 times 2. 33. So that's 33 panels over here. Minus rooms is side times side, so 3 times 3 minus z. So that's 9 times 7. No, 9 minus 7, that's 2. If my so number of panels minus equals 1 plus. Right, so let's sketch. Let's make a sketch of that real quick. So, because you can get 8. 3 by 3 cube is 27. So I'm gonna draw it on my piece of paper over here. You can also draw it on your piece of paper, but I know that nobody is watching, so whatever. Alright. Alright, so the thing is that there's 3 times 3. Alright, so 2 of them are black. And so there is 1. There is 1, 2, 3, 4, 5 of them less. So it's minus rooms is 2, and then here is also 2. 2 times 2 is 4, plus 1 is 5. So number of panels is now number of panels equals to 3 minus, what's that, 5, equal to 28. So we return number of panels, which is 28 plus 28, and that amounts to 103. 103. But it should be 102. So where's the problem? I think that the problem... Oh. Yeah, so let's just make a quick print statement over here. Where did we go? We were over here, yeah? 7 rooms left to construct. No? Where were we? Over here. Yeah, with this one. 1 plus 2 minus rooms. So we say print, we are deleting rooms. And if this print message is gonna be besides error messages, we'll know what's up. Okay, so here it pans out, here it doesn't pan out, here it doesn't pan out well, here it does not pan out well. Here something else is the matter, here something else is the matter, here is the matter, here is the problem, here is the problem, and then further we do not know. And then max buffer size reached. Alright, so there's something wrong with this logic. Because here we are removing 1, 2, 3, 4, 5. I think we are removing 1, 2, 1, 2, 3, 4, 5 thingies. And we want to always delete like the maximum amount of panels, you know. So by deleting the maximum, like, I don't understand, there's 5 of them, right? Yeah, 5 of them, right? Well, apparently not. Apparently I'm counting one too much. I guess there is one too much. I'm saying there's 5 less, but there's only 4 less. So let us see. If we just remove this +1, if we turn that to 0, are we gonna get less error messages? Well, we forgot to count the error messages before it. Yeah, but now we got at 7, at 25, and at other numbers, you know. And if we say here +1, yeah, so I guess there needs to be there needs to be some kind of a condition over here. Like, and yeah, it is with deleting shit, you know. And I bet even like if we copy that print statement and we paste it over here, that's how we are gonna collect all of the, like, that's how we are gonna mark all of the error messages. Now I bet if there's gonna be an error message up before it, we shall see this print statement. Yeah, print statement, print statement, print statement, print statement, yeah, that is our problem now. And we do not understand it properly. We do not understand it properly. And that's the problem. Because you need 3. Oh, because it's also 1 in between. So number of panels each time you remove it, it's 3 plus 1. No, it's just 3, I think. 3 minus room. Let's see. Oh, I should again count them. Okay. Well, but now the problem is at 10. Again, with deleting rooms. Let's see. Let's just write this in lowercase. Just like add a bunch of exclamation marks and see if that gives us trouble. And I think that gives us trouble, indeed. Yeah, it gives us, yeah, 1, 2, 3, yeah, a bunch of times. Fuck. So let's print out in both of them. Print out the oops. We say in both of them. We're gonna say side is, oh, and we need a f string. Side is shit. Side is side, and minus, fuck you, minus rooms are minus rooms. Alright, so firstly let's fix this one, because I think if there is like the same amount of size and 2 minus rooms, 2, 2, then here's 3, yeah, and so on. It should be 2 plus 2 times that, but actually it's like, let's see, it's like first it's 1, 2, 3, 1, 2, 3, 1, 2, 3, 4. So yeah, so it's actually 1 plus 3 times minus rooms. So now I'm expecting to not see we are deleting rooms error. Yeah, it's alright, that's solved. Oh my god, congratulations to us. We can congratulate, we can congregate ourselves. Alright, now for this motherfucker. So yeah, let's just delete that one. Make an attempt again, so everything is more clearer. Okay, so side is 4, minus rooms is 5. Oh, yeah, we got more. Yeah, I thought so. We got more minus rooms than there is space, and that's what's happening. Because I thought it is impossible. Yeah, it's always more minus rooms. Side 2 minus rooms 2, and there is an error. Why? Alright, that is just silly. How is side is 2 minus rooms is 2? Okay. Alright, so there are some special cases around here. Side is 2 minus rooms is 2. Well, okay. I mean, we have advanced, you know, thank God for those tests. Fuck. And here we notice mismatch of 1 that is gonna boost our spirits more. Here we see a mismatch of 1, here we see a mismatch of 1, here also mismatch of 1. Yeah, okay, here is mismatch of 4. Here is a mismatch of 1 again. Here is a mismatch of 1. Here is a mismatch of 1, so it's basically just mismatch of 1. Except here is somehow, oh no, it's again mismatch of 1. It's always 7, 3, 7, 2 as here. It's always 1, 2, 3, 1, 2, 3. It's always 1 too much. It is always 1 too much. Alright, so if we use our so-called peasant logic and we say -1 on all of those, are we gonna get errors? Yes. Alright, so we need to differentiate. Are all of these examples such that side is less than minus rooms? Yes. Yes. Okay. Alright, so we do elif minus rooms equal to the side or minus rooms is greater or equal to the side. Then we just do what? We do that, right? Copy paste. Just -1. Test it out, all pass. Yeah, what about this one? Oh good lord, please. Let this quick. Of course. Oh, now 2 to 6 should equal 2 to 4. And if we comment it out, do we still get error for 5, 9? Yeah. Side 4. Minus from 5. Let's see if we solved anything. What an excellent printouts. Excellent console prints on Rock's part. Question marks, question marks, question marks, question marks, question marks. Like why? Oh, +1. It should be +1. Fuck. It should be +1. Let's make an attempt. Okay, so now everything works. So now our fucking code works. I kinda don't know how. But alright, so yeah, so let's just say if number of panels are more than side. If it is peeking over, so to say, there is something, but I don't know what, man, I don't know what. Alright, so we just delete all this print. Alright, so if you're wondering, yeah, we just found out the third way, or I don't know, right now the fourth way to solve this kata. We shall just see if this instance is appropriate for this format, where we count to one fucking quintillion. What the fuck? Quintillion, bro. Alright, so let's see. 9, 8, and up until when? Where did it get our last? 9, 8, 8, 3, 6. So this time it's a faster. Alright, 9A836. Now let's see, does it run faster if we return? No, if we delete all the comments. I don't know why it runs faster, it just does, I don't know. Even though I think we added more code. Okay, focus on a far point in the distance. I'm gonna look at my green door, my trendy green door, which is very trendy in nature. and also smakalik. Delete that, delete that, delete that, delete that, delete that. Alright, so now we are at 9A836. Let's try it again. Oh. Okay, we are printing it. 9A836. It is still the same. Alright. But now we can at least follow this guide. It says, get it right. Test it right. Well, we are testing it right, I guess. Profile it if slow. Optimize. Okay, what the fuck. Example would be moving the calculation of values that don't change within the loop, outside of the loop. Certain optimizations amount to good programming style, so should be learned as you learn the language. TBD. What does TBD mean? TBD meaning to be announced. To be declared or what? Sorting. This is for sorting. I don't need to sort anything. Yeah, I do not need to sort anything. String concatenation. Well, loops. Alright, Python supports a couple of looping constructs. The for statement is most commonly used if loops or the elements of sequence, assigning each to the loop variable. If the body of your loop is simple, the interpreter overhead for loop can be a If the body of your loop is simple, the interpreter overhead for the for loop itself can be a substantial. This is where the map function is handy. You can think of as a map as a for moved into C code. The only restriction is that the loop body of map must be a function call. Besides the syntactic benefit for its comprehensions. Alright, so this R code actually never uses for loop. Never. So this thing is no use for us. Avoiding dots. Suppose you can't use a map or list comprehension, you may be stuck with the for loop. The for loop has another inefficiency. Both new list, append, and word upper are function references that are re-evaluated. The original loop can be replaced with... so you avoid dots. Something dot something. Let's see where we have it. Well, apparently never. Our code is pretty well optimized right now as it is. Local variables. The final speedup available as for the non-map version of the for loop is the use of local variables wherever possible. If the above loop is cast as a function, upper and append become local variables. Python accesses local variables much more efficiently than global variables. Initializing though dictionary elements, suppose you're building a dictionary of word frequencies and you've already broken up your text into a list of words, you might execute something like word dictionary for word in words. If word not in dictionary, verdict word year 1, else do that. So okay. Except for the first time, each time a word is seen, the if statement test fails, you're counting a large number of words. Many will probably occur multiple times. In a situation where the initialization of a value is only going to occur once, and the augmentation of the value will occur many times, it is cheaper to use try statement. Once, and the argumentation will occur many times, it is cheaper to use try statement. Okay. Okay, so that's a little bit more of those mental gymnastics. Try statement. Well, just a second. That gets me thinking. What if we comment out this global function call, which we know is expensive, and also this, and just attempt that. And kaboosh. Yeah, execution time that. Okay. Alrighty then. Fuck. Okay. Okay. Try and accept. Alright, we're and try and accept. I guess the dictionary elements, but we do not have dictionary elements. But still, like, try accept statement here. Yeah, I mean, we do not get an error with using try and accept statement. I guess try and accept statement are lame. Alright. It is important to catch the expected key error exception and not have a default except clause to avoid trying to recover from an exception you really can handle the statements in the try clause. A third alternative became after with the release of Python 2x. The dictionaries now have a get method which will return a default value. Alright, import statement overhead. The import statements can be executed just about anywhere. It's often useful to place them inside functions to restrict their visibility and or reduce initial start time. Okay. String methods were introduced to the language in Python 2.0. Here is the proof from Timeit. Good for you. Data aggregation, lazy. Function call overhead in Python is relatively high, especially compared to the execution speed of a built-in function. This strongly suggests that appropriate functions should handle data aggregates. So import time, data aggregation. What the fuck is aggregation? A mass composed of many distinct parts. List range, time, whatever. So what's even written? A second example runs about 4 times faster than the first, or this than this. So what's import time? X is 0, def do it 1, global x plus I. List is range is big list. T is t time. And for I in list, do it and then print whatever that is. So that's okay, and then do it global for I in list. Exchanging a Python for as well as data aggregation. So what is data aggregation? I do not understand that. Is the compiling of information from databases with intent to prepare combined datasets for data processing. Do it E. What is I? Import time. What is I, bro? Fuck. What is I? X plus I. So, we got some kind of a input. Do it one I. For I in list. Okay. So for every I in list so for every number from like 1 to what 100,000, you do x, yeah, x plus 1. But over here you just do it in one time, just that you like assign list here. Yeah. Function called. Oh, so if function is called too many times. Okay. Functions should handle data aggregates. Data aggregation dummies. Except summarizing data, finding totals and calculate and fuck. Not new to you. Well, they are. Big data. When you need your summaries and for process is called aggregated data can become the basis for additional calculations. Here is an example of data aggregation process. A dataset contains general information. Wow, there's a lot of stuff, you know. For programming, data mining for dummies. By Meta is pro. 4 parcels of real estate. About this data includes a variety of land uses. What if you'd like to see average assessed value for the land? Find the data aggregation tool in your data mining application. You might use search to find it. Aggregate. You'd add a tool to a process and connect it to a source data set. I think we do not have to worry about this thing now. Doing stuff less often. The Python interpreter performs some periodic checks. In particular, it decides whether or not to let another thread run and whether or not to run a pending call. Typically a call established by a single handler. Most of the time there's nothing to do, so performing these checks each pass around the interpreter loop can slow things down. There is a function in sysmodel check interval which you can call to tell the interpreter how often to perform these periodic checks. Prior to the release of Python 2.3 it was defaulted to 10. This is raised to 100. If you aren't running with these threads, okay, Python is not C. Be careful when transferring your knowledge per Python. A simple example to demonstrate. So it says this is slower than that. X times something is slower than something plus that. Wow, okay. So, okay. Thank you. Alright. So that is the first thing we can do. (9A836). So here we are with 9A836, where we are here, like copy, paste, minus 9A836 2176. Yeah, we advanced a little. So then we just say, like, if this is true, alright, let's not trust that motherfucker, let's do it for ourselves. We say Python quit, say Python 3.m time it x equals 47 and x times 2. It's like that, and if I say x plus x, well, that is much faster with me than over here. To 6. So there is not much difference. So what if we do a really big number? 365 x times 2, 364. It seems that the that plus is indeed faster, but just a little bit. This is 359. That times 2 is 377. Alright, so let's change every that into that, you know what I'm saying. So 2 times x is, say, just x plus x. 2 times y is y plus y. X times y, you can't really go around that. Y times okay, that's that. Size times size times size, you can't really go around that. 3 times something, I won't go around that. N times n, I also won't go around that. So we're here. Let's make an attempt and we see if we have made that faster, at least for one test case. Don't forget to stretch. 98836. Where were we? 9883. Yeah, nothing changed. Nothing changed, man. Well, okay. Fuck. The execution time. Section no longer applies if you're using Python 3. Remap functions at runtime. Profiling code. The first step to speeding up your program is learning where the bottlenecks lie. Hardly makes sense to optimize code that is never executed or that already runs fast. I use 2 models to help locate the hotspots in my code. Profile and trace. Letters example, I also use timeit model, which is new in Python 2.3. The advice in this section is out of date. See the separate profiling document for all alternatives to the approaches given below. The scan is fast. It's fast, it's precise, it's smack-click, a high-performance CPU. Alright, Chinese version. There's a number of things that other Python would do. It has issues. Interesting. Alright, so. So we got an interesting output using on a provided example program. Test.me.py. Alright, let's do that over here. ls. So we say Python 3 vinv, and we call it virtualenv. Say pip install u scaline. Python. Oh no, we need to source virtualenv, activate, and then pip install. Okay, and how do we use it? We say scaline appy object cannot be preloaded, cannot open shared object file. Alright, so let's go to success stories. Logo created by Sophia Berger. Check out the LinkedIn page. Alright. Is there like a troubleshoot section? No. Okay. There is no troubleshoot section. Let's see. Scaline. It says usage scaline help. Show this help message and exit. Well, I need to go to the toilet now. So let's try to use this tool called scaline with this code copied and pasted. Copy, paste. Panel count is here. Well, this is third try. You know, third time's the charm, as they say. How we say panel count, and we say that high number. What's that high number? It's not here, am I right? Oh, it's in the comments. I know I can mark it as a spoiler, but since like nobody has touched this kata, it seems, for some time now, I won't, or maybe I will. Spoiler. Paste that here. Now we try to run that thing. Okay, nice. Okay, so what happens? from cannot be let's search it up. And now I have really lots of apps opened. From LD cannot be preloaded, ignore it. The linker takes an environment. Okay, some local thing, I guess not connected. Cannot open shared object file. App. Percentage of time is 1000 of 15. 0. Oh yeah, the good thing is that it can actually like return a value. So something 65, 8 something, I don't know. Time in Python, time in native, sys. Time in Python, time in native. So that's 65. And that's yeah, that's not really helpful, you know. Alright, so this thing here, Scalene is fast. Scalene homepage already went here. Native code. Memory. Yes, so we supposedly do not have any native code. Yeah, because we're not importing anything. That's equalong. Profile copying volume. Python that log obviously in the above is program being profiled. Args are the desired arguments to be supplied to the program, if any. If the O option is omitted, the default O output value will be chosen based on the name. Visualizing the output. Okay, so do we have like a Bolut? Yeah. Solution.pyc. What? Okay. Still don't really know what to do with this one. Technical information. Installation. Using the following command, run Scalene on a provided example program. Oh. On a provided example program. Is there a provided example program? Scalene test me py. Could not find input file. Okay, so where is that test.testme? Test and test me by. And I think we can find it inside virtual environment. So it says Scalene virtual environment, and I think we do the include. Alright, nothing in there. Lib. Scalene. Yeah. Test. Shit, test. It's not there. It is not there. Let's go. Oh, shit. Okay, so we go back. Let's check out the bin. Salina. Okay. Library 464 Python side packages. Salina again. And there is just no. Oh fuck, we need to go into pip. Let's go into first normal lib. Side packages, we say pip. Then we have Salina here. Status codes, no. Lib45. Yeah. Pip. Is here Salina? Well, where is this? Where is this? I cannot find it. Says touch test me dot py. And we have this thing called test me dot py, whatever. Raw. Fuck. Oh my god. Copy. Paste. Yes, save. Just say test me. Okay. Ooh, okay. So we say time in native. 7 seconds. Okay. Some weird stuff. CPU memory and scaling. Pointing to the specific lines of code that are responsible for the execution time in your program. Alright, so if we do that with this one, and this program wants to say that lots, like here, time is spent here, and time is spent here, and a lot of time is also spent here. Okay. So we I think that's our bottleneck. So we say Python make a while loop faster. Huh. Well, so what is NumPy? Powerful n-dimensional arrays. Numerical computing tools, easy to use. Enable. While we wait, launching container on my binner. Don't forget to check out the docs. Enable. Case studies. Einstein predicted gravitational waves. 100 years later, he's still on warfare. Run, Shift, Enter. Shift, Enter. Yeah, my ass it runs. Ah, okay. No, I can't type anything. I can't snipe anything, and I can't bipe anything. Okay. Okay, this dude is called Godot. From the PLC. Okay. How did I get to NumPy? Oh, with while loops. Well, while doing that, I got another idea. And we shall go like so. We shall say Python documentation, lucky. Just get like language reference, syntax, data model, import system expressions, arithmetic conventions. When a description of an arithmetic operator below uses the phrase the numeric arguments are converted to a common type, this means that the operator implementation. If either argument is a complex number, the other is converted to complex. Otherwise, if either argument is a floating point number, the rest both must be integers and no conversion is necessary. Atoms are the most basic elements of expressions. The simplest atom are identifier or literals, forms enclosed in parentheses. Wow, that's a lot. Yield expression, generator expression, next. Stuff like that. Lambdas, operator precedence, so exponentation. That is exponentation. Is it exponentation of the human nation? So here we were at for this scale Python. Wait. Just say clear. Go back. And we just say x times x x times x times x takes how much? 0.7. Alright, much more. if I just says x exponented by 3, it's even slower. So you want to say x times x times x is faster than x3. Say what? So you say 3 times 3 times 3 is 27, and 3 to 3 is 27. And do you want to say for real? So let's say just that. So this is 0.00975, 0.0, wow, okay, so I guess if I use, for example, here size exponented by 3 and here size exponented by 2, it shall be much slower like than that. So let's make an attempt. It's Python 3.6. Alright, so let's see where it comes from. Oh, max buffer size reached. I'm sorry. Oh, okay. I think we got, I don't know. Oh, I see. There's some cookie malfunction in this code. I see some cookie malfunction in this code. Because, I mean, in this website. This is cancelled, and this is cancel culture, and this is cancel culture, and this is cancel culture, and also this is cancel culture, and this is cancel culture, and we see we get 836. It's all the same. It's all the same. Why is it all the same, man? Why is it always getting to 388? No, 98836. It's always getting to 98836 now. Why? And apparently nothing can change that. 98836. Okay, if you just say here def dump function and say for in range, let's say we want to count that, maybe that, just say b equals to over here we just call it dump function. Now I am expecting less wow, yeah, it's much less. All right, on to optimization. So this thing change nothing, like these exponentation symbols. And it's here that it is making the problem. So if we say if size equals 1 plus size, what if we just do that? Nothing happens. So you could just say that since most of the time is wasted there, we could use like if let's just print x, you know, make an attempt. My stupid phone is on again, I need to like turn it off. Fuck it, telephone, more like shitty phone. Like 9. Hold up. If I use a print statement, there are more things running. Say what? Okay, print x is x and size is size f here, and we comment out these few things. X is, yeah, so let's go over here. X starts at 2. X goes, and then max buffer size is reached. Maybe we could just say X and that. Look, the longer it takes, that means the buffer is longer to make. And this is called exit code 1, timed out, 99694. It's always 99694. The execution timed out. Okay. Let's just call this panel content, and you again see def panel count n, just print out n, attempt. Hey, was my microphone muted all the time now? Let me check. Oh, I can't. Well, fuck it. Fuck it, you know. Oh, and the test even failed. Ah. Okay, so here we are over 1. Like around that number, whatever this number is, I don't know. Oh, and I guess this is the limit of our thingy. So there may be that our function runs don't even reach this big of a number. So let's just say here if x is greater than, how many zeros are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1, 50, fuck. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Print that. And I think the program does not even reach that one. Yeah, it doesn't even reach that one. So we must pump up the size. You know, we must implement a rule here that makes it faster to run. So there needn't to be that many cycles in the loop. Because it's over here. Size is 3, 3, 3, 3, 3. It's over here that size becomes really large. So we say if so right over here says execution timed out. 99694. Here we say it's 10. We say if x is larger than than 1000, size is 10. Also, if x is larger than, where should we count it from? Here. I'm just like picking arbitrary numbers. 9261. 9261 size. So it's 9261 size. Let's start at 22. over here to speed these things up. Something in between 37 so we say if x is greater than 46656, then size equals 37, else it's 1. Or like, let's pick 1 for the really big numbers, because we can also say if x is greater than 99694, then size equals 247. Alright, let's make an attempt with that. I hope the code will get further. And I guess we could cancel this line of code. It's exactly the same. I do not understand it. Only in Python, only in that. Like, do you want to say that nothing changes? It seems weird to me that seemingly this if statement does not affect. So 99694 I bet again we shall be at 99694. So that like if does not change anything, I guess. I guess it ain't such a big deal after all. I don't know what to make of this so-called report. And like, what if the problem is with lower numbers? We say something like that. Alright. Program did not even run long enough to profile. So it says program did not even run long enough to profile. What about now? 45 on 160th line. 20 over here. I guess because it has to do so many iterations. Also here. And what if we include that little hack over here? Just say if x is if x helping us with this one, say like it doesn't take that long. Just the sheer amount of times it has to do it that makes it slow. Alright, do you think is there a way to make this code even slower? Number of panels in cube n. And it takes like too long. This code will crash when it takes half a second for just one instance of a problem. Or even if you use the real problem. Like we go back up until here. Let me test that. So that takes 0.15 seconds. Alright, that's not that much. That could be doable, but there's like I don't know how many of them. If you say right here, call it panel, or this panel count, and say function calls, and here global function calls. Oh, and we look. We say if n is over and vad är 4 pages och sen 17, then we say function calls plus equals 1. Then we print n. Also, and just print function calls So we see how is the amount of function calls times 0.15. Wow. 0.00000. Yeah, that's quite some of them. Yeah, that's too much. Like we say 905 times 0.15. I think that's in decimal, not in seconds. That still isn't it like a whole more than 2 minutes. So we have from multiple centuries we have lowered the execution time of our kata to less than 3 minutes, or even less than 2 minutes and a half. But this needs to be done in fucking 12 seconds. So yeah, I shall finish this video here, make some dinner, think about it. And then see you. Oh, forgot. And like this tool does not help. This tool, like that tool, fucking. I guess I just don't know how to use it. But this tool called Scalene. Yeah, more like I don't know how to use it. Lean. Yeah, what? The 98836 function calls. Yeah, we stay at 98836. So yeah. And do we